All right, so 11.4 is fundamentals of probability. So theoretical probability of event E. So what theoretical probability means is in theory. So if you were to flip a coin, you have two options, heads and tails. So out of, what's your probability of landing on a heads? 50%, right? That's just supposed to be in theory. That's based off of, because there's either a heads and a tails. So theoretical probability means in theory. The theoretical probability of an event is denoted by, is written by the probability of event E. The probability of event E. In order to find this, it's going to be the number of outcomes in E number of outcomes in E divided by the total number of possible outcomes. So for example, if we flip a coin, the probability of getting heads would be one option out of two options total. Landing on heads, you'd have one option out of two options total, so you have 50%. So that's in theory, that's theoretical. Questions so far? That's like our normal probability that you're used to seeing. So probability that is based on situations in which we observe how frequently an event occurs is called empirical probability. Empirical probability. So for example, if they ask me the probability, what's the probability that a student's going to come in late? I would sit here and I would literally count down and see how many people are going to come in late. So it would be like I literally watch you walk in late. It's an experiment. I literally observe you doing it, so it's empirical. It's not in theory. In theory, it's supposed to be 0, right? Now it's supposed to be late. So this would actually be an experiment, and I actually watch to see what happens. We observe how frequently it occurs, so it would be empirical probability. So for probability, ranges from 0 to 1, or 0% to 100%, because we can write it as a fraction, or we can write it as a decimal, or we can write it as a percent. So if something has a 0% chance of happening, or 0 probability, it's totally impossible. All the way to 100% probability, or chance of 1, which means it's automatically going to happen, there's no other option. And then anything in between would be a fraction or some type of percentage, which would tell us how likely or unlikely an event would occur. Questions about that? So the sum of the probabilities of all possible outcomes in an experiment is going to be 1. So going back to my stress ball, this is a good demonstration. So say if I had stress, let's make it a little more easy. So say I'm hogging 3 of them over here. I guess I was a little stressed. I'm good, thank you though. So say I had this orange one and I had this red one in here. I'm going to say, what's the probability of me getting the orange one? What's the probability of me getting the red one? That's the only 2 things in here. The other one's going to be is orange too. So it's the only 2 things in here. So I get a probability of the orange ones, a probability of the red ones. Adding them together, my sum is going to be 1. That's the only option. So adding all your options together, our sum would be 1. What's my probability that I reach in here and grab a ball? I'm going to grab one every time as long as there's some in here. So that's what that means. So let's actually do some examples. How could I help you so far? How can I help you so far? So example, if you have a 12-sided die that is rolled, find the probability of rolling a number less than 12. So if you have a 12-sided die, so it's like 1 through 12, what's the probability of rolling a number less than 12? So how many numbers are less than 11? Sorry, less than 11. How many are less than 11? There's 10 of them, right? Okay, so let's say our outcomes, just for our note's sake, if we roll a 1, a 2, a 3, 4, 5, 6, 7, 8, 9, and 10. 11 is not less than 12. 12 is not less than 12, so both of those don't count. So those are our different options that are less than 11. How many options are there total? Huh? You have 10 on the top, but 12 on the bottom? So we said there's 10 different options up top, 12 options total. So 10 out of 12. Can this be simplified? Yes, what does 10 and 12 have in common? 2. So I can factor or divide out of 2 from the top and the bottom. So we're left over with 5 over 6. Done. Final answer. 10 options are less than 11 out of our 12 total. So we have 10 out of 12. Simplifying that fraction, we get 5 over 6. Questions so far? You still feeling okay about this? All right, so next we have a 6-sided die that's rolled. Find the probability of rolling a number that's less than 14. So how many numbers are less than 14? Out of 6 sides. 6 of them, right? So our outcomes. It's only a 6-sided die. So 1, 2, 3, 4, 5, and 6. So everything is less than 14. So all of those 6 sides would count. Out of how many total? 6. So we have 6 options out of 6, which would be 1. Good. 6 divided by 6 is 1. So if I roll a dice, every time I roll it, I know it's going to be less than 14. So we have a 100% chance. We are certain that every time I roll it, it's going to be less than 14. How could I help you so far? Yes, ma'am, please.
So we can leave it in fraction form. We don't have to like change it to a percent or anything.
Yeah, no, I think it asks you to leave it in fraction form.
Oh, okay.
Yep, so when I look on my math lab, it'll say fraction form. Great question. But make sure it's simplified. All right, so you're dealt with 1 card from a standard 52 deck of cards. Find the probability of being dealt a diamond. So how many diamonds are in a whole stack of cards? 13. So 13 diamonds. Full disclosure, I didn't know that. I don't like these because, like, what if I don't know about cards? You guys all know? You guys look at me like I'm dumb. I don't know.
No, I get you. I'm fine.
No, I don't. So 13 diamonds. I mean, I knew it was 1/4, so I was kind of nerdy, and I was like, okay, well, if it's a fourth of it, right? Nerdy? Yeah, I know. All right, so how many are there total? Yes, ma'am.
On the test, is it gonna ask?
If you don't know it, just ask me,
Okay.
and I'll tell you. I don't know, because I don't know what the test or the final is going to be like yet. So if there's anything like that, just let me know. I could definitely tell you something like that. Because I don't want that to stress you out, because that would stress me out. All right, so 13 diamonds. How many cards are there total? 52. See, we're giving you good life skills in this class. You learned about cards.
Where's your gambling addiction come from?
Yeah. Blame my math. All right, so 13 out of 52. Let's simplify this. What do 13 and 52 have in common? 13, good. So they both have a 13 in common. We can simplify that by dividing it out. So we're left over with 1/4. By the way, our calculator, because I've seen a lot of us whenever we went to simplify this, we're like, oh. So on our calculator, if we have 13 divided by 52, it would help if you could see what I'm writing. 13 divided by 52, press enter, we get 0.25. So turning this from a fraction to a decimal or vice versa, do you see above the PRB button? So in light blue, so we're hitting our second PRB button, is asking us to turn our answer from a fraction to a decimal or either way, vice versa. Press enter, 1/4. It simplifies it for us. On our graphing calculator, these folks, we have 13 divided by 52. Can you see it all? There. Press enter. Hit the math button. So right here, math, into a fraction. Press enter. Turn your answer into a fraction. Press enter. Boom. So it'll simplify it for you. Good. Questions about calculator stuff? All right, let's do another one of these. So if you're dealt one card from a standard 52 deck of cards, what's the probability of being dealt a jack and a 9 in one card? One card. You're only dealt one card. So is there one card that is a jack and a 9? What's a jack? A jack is like, what are they called? Are they a royal? No, a suit? What's it called? No idea what's happening. Okay, never mind. So you know you have like jacks, kings, and queens, and aces? They're called something.
I don't remember anymore.
I don't know. No one knows. What? A jack, a king, and a queen, and an ace. Face cards, yes, thank you. Face cards, right? I don't know. Okay, whatever. I don't know about cards. So, out of the face cards, could it be a jack and a 9 at the same time?
What?
No. It can't be a face card and a numbered card, right, at the same time. So there's no cards that will have that. If you're only given one card, you're not going to be given both. It's like you're not going to be given a 2 and a 3 if it's only one card. Does that make sense? All right, so there's no card that has both of those. So 0. Jack and a 9. Not diamond. The key word is and. So get both of them. 0 cards are both a jack and a 9. Or if it said how many are 2 and 3. There's no card with 2 numbers with 2 separate names on it. So 0 cards out of how many cards total? 52. 0 divided by 52, 0. There is no chance that's impossible. Kind of weird, that's why I put it on here. How can I help you so far? Yeah, the way it's worded, I agree. Plus the number of 9s, exactly. But the big thing here is you're only dealt one card. So find the probability of being dealt a jack and a 9 at the same time. Oh, I see what you're saying.
Yeah.
Yeah. No. Yes, ma'am. Yes. Yes. Okay. All right. So next, I see your thing. The answer is 0. Yes, and it's or. Bingo. If it's or, that's the a being dealt a jack or a 9. Bingo. Okay. So a single die is rolled twice. So that the 36 equally likely outcomes are shown. So if you roll a 1 and a 1, a 1 and a 2, so on and so forth. So find the probability of getting 2 numbers whose sum is 4. So which one of these add up to 4? Okay, 3 and 1. 1 and 3. 2 and 2. Anything else? If it's 4, it's going to be too big. 5 is going to be too big. 6 is going to be too big. 3 and 1 is our only option. We got both of those covered. 2 and 2 are our only other options. Got both of those covered. Nothing else works. So we have 3 different options. So 3 different outcomes out of how many total? 36. How can I simplify 3 over 36? What do 3 and 36 have in common? 3. So we can factor, divide out a 3 from the top and the bottom. We're left over with, 1/12. Final answer. 3 more. 3 more examples. How could I help you so far? Staying with me? Decent? Last 3 examples. Last 3 examples. So this use the spinner shown to answer the question. Assume that it's equally probable that the pointer will land on one of the colored regions. If the pointer lands on the borderline, we spin again. So if the spinner is spun once, find the probability that the pointer lands on a region that is red or yellow. Here's your word. Red or yellow. So how many are red? 3. How many are yellow? 1. So how many options do we have total? Outcomes? 4. Out of how many total? 6. We need to simplify this. What do 4 and 6 have in common? 2. So we can simplify this down 2/3. Done. Questions for me? Again, use the spinner to the right. If the spinner is spun once, find the probability that the pointer lands on a region that is blue and yellow. So, here we go with the and. So how many regions are blue and yellow? None. There's none. I can never spin this and land on both of them because I know if it lands on the line, we spin again. So there's no options that I can spin on both of them. So we have 0 outcomes. Out of how many total? 8. You're right. So 0 divided by 8, 0. So cannot land on both. So that word and versus that word or is a big deal. So the first one was or, so it can be yellow or red. This one is both. It can't land on both, so 0. Yes. Total different options. So whenever it says or, you add how many red plus how many yellow to see what is your outcome. Other questions? Last one. Other questions? All right, so last one, we have a table. This table shows a number of expressed in millions of citizens who moved in 2004, categorized by where they moved and whether they were an owner or a renter. Find the probability expressed as a decimal rounded to the nearest hundredth that a randomly selected citizen who moved in 2004 was a renter. All right, so we need to see how many renters are there total. How do I do that? Add them all up. So we're going to have 18.6 plus 4.4 plus 1.1. So total we should have 24.1 renters. Do we agree? $24.1. Out of how many people total? So we had that 24.1 plus 11.7 plus 2.9 plus 0.4. I got 39.1 people total. Do we agree? For the whole chart?
Wait, so is it a number or is it added on top of the number?
Yeah, so it doesn't say anything about moving from a different region, same region, it doesn't say anything like that. I just want to see renters in general. So in general, there's 24.1 renters total. Out of how many people in general? And we got 39.1 million. This is in millions, so million. So total we had 39.1. We want this as a decimal, so we're going to divide these two things out. So 24.1 divided by 39.1. 0.616368286. Blah, blah, blah. We want to round it to the nearest hundredth because it told us in the directions, round to the nearest hundredth. So hundredth is rounding what number? The 1. Second one over from the decimal, rounding the 1. Looking next door is a 6. You know, if it's 5 or higher, it's going to round up. So 0.62. About 0.62. And that is all for 11.4.